right, so yesterday where we left off, I told y'all don't let me forget this. Nobody reminded me. We did that example. Example 2 that was not a triangle, right? Because side A was shorter than our height, and so that cannot be a triangle. Sometimes kids don't actually check to see if it's a triangle first, or if it's a right triangle, or if it's two triangles or whatever. So I was going to show you, if you did not check, another way you could know that this is not a triangle is to do some math, okay? Or when you start doing the math to solve it, because you didn't check first, I'll show you what's going to happen. It's going to let you know, A, either you just entered it wrong into the calculator or set it up wrong or whatever, or B, it's not actually a triangle, and that's why this is happening, okay? So that's where we left off yesterday. I just didn't have time to show you because the bell rang for lunch, all right? So let's just make a little note. If you didn't check the SSA triangle to make sure it's a triangle first, you will be able to tell when you start trying to solve it. Let's remember, this is continuation of what we were doing yesterday. Ambiguous case. When you have a side-side angle, triangle, or you could call it angle side-side, but that abbreviation is a bad word. So we call it side-side angle. You could pop, it's ambiguous. Those kinds of triangles could be several different things. It could either be not a triangle at all. It could be a regular old triangle. It could be a right triangle, or it could be two separate triangles, right? That only happens on triangles where you're given two sides and an angle, and the angle's not included in between the two sides. That's when this happens. So that's why you're supposed to check first before you start solving it to see what it is, okay? Because it might not even be a triangle. Or it might be two triangles and you need to solve both of them. If it's two, you got to solve both, okay? 2 for 1. All right, so let's go. We were looking at this triangle here. Say you didn't check, okay? So you're like, okay, I know angle A and the leg across from angle A, so I'm going to use A over sine at A, and I'm going to use B over sine at B to find angle B, okay? So I'm using the example from yesterday. So I'm starting with A over sine at A equals B over sine at B. And you'll already have these notes above, so I'm not going to keep moving my paper. So A was 51 over sine of A is sine of 75 degrees equals side B was 71, and we did not know angle B, so we'll just put sine at B. Okay, so y'all know you can also, if I just have a fraction set equal to a fraction, I could do like we did yesterday, multiply both sides by sine of B, right? Or actually, we can do something a little quicker as well. Do y'all remember what cross product means? When you have a fraction set equal to a fraction, you can find the cross product. Or you can solve it the way we were yesterday too. But cross product a lot of times will give you the answer quicker. So cross product, sometimes kids say cross multiply. There's no such thing as cross multiply. That's not actually a thing. It's called cross product. So I would do 51 times the sine at B equals, you must put an equal in between, and then do sine of 75 times 71, but I'd probably write that 71 first so I'm not confused. 71 times sine at 75 degrees. You're doing the same thing as the way I showed you yesterday. It just looks a little different along the way. So if I'm trying to solve for a sine at B, what would I do next? Divide by what? 51, because I want the 51 to go away and just leave me with sine at B. I have to do that to both sides. So the sine at B equals, y'all put 71 times sine of 75 degrees, quantity divided by 51 in your calculator and tell me what you get. What is it? 1.34? Okay. Now that's the sine of angle B. Is that the measure of angle B? No, it's the sine. So if I know the sine and want to find the angle, what do? Inverse. So I need to find sine inverse of 1.34, and that will give me angle B. So what is that? 1.34 second sine error. Why do you think it's giving us an error? Because it's not a triangle. So, but be careful, because you could also get an error because you did something wrong. Okay, so make sure of that first. But if you didn't do anything wrong and you're getting an error when you put in a sine inverse, then it's because it's an ambiguous case. All right. So also make yourself a little note of this. Another little important factor. Because sine can never exceed 1, and right, we had sine of 1.34. So because sine can never exceed 1, this is a key indicator that this is not a triangle. Yes? Were you supposed to leave a packet of papers and attendance for payolas? No, I was supposed to leave them in guidance. They should be on their counter and they're labeled. Okay, thank you. You're welcome. All right, we good with this? Okay. Example 3. We're going to solve triangle ABC if A equals 40 degrees, lowercase a, so we're talking about a side, equals 54, and B equals 62. Round lengths to the tenths. And angles to the nearest degree. So remember, this is a side angle, so I don't really know about that third side, so I just kind of do a dashed edge. Okay, so we have a side angle triangle, correct? We know two sides and an angle that's not included. If the C was 40 degrees, that would be a side angle side. That's different. But if the angle's not included, then we have a side angle. These could be ambiguous, okay? So we need to check and see, do we have a triangle? Is it a right triangle? Is it two triangles? Is it no triangle? And to do that, first of all, we need to know the height. We need to figure out the height. And we learned last class to find the height, you do B times the sine at A. And B is whatever leg that's not across from the angle you know. A is whatever angle you're given, right? It's not always going to be labeled triangle ABC. So that would be 62 times the sine at 40 degrees. Y'all put that in your calculator and tell me what the height is rounded to the nearest 10. 39 point, I have 0.8 written down. Let me do it real quick. So 62 times 40 sine equals 39.9. You're right. $39.9. Okay, so first of all, you can start with whatever you want. I'd start with seeing like, okay, is it just one triangle by itself? So if it's one triangle by itself, A has to be greater than H. Is A greater than H? Yes. And also, A has to be greater than B. Is A greater than B? No. 54 is not greater than 62. So it cannot be one triangle. Okay, let's see if it's a right triangle. And we wrote all these down yesterday on like the second page of our notes. To be a right triangle, A has to be equal to H. Is A equal to H? No, so it's not a right triangle. Well, is it even a triangle? If it's not, A will be less than H. Is A less than H? No. So we at least know it's a triangle, right? It's not going to be one of the, if it's not a triangle, we can stop there. It can't be solved because it's not actually a triangle, because side A will not actually go down and reach side C, okay? But so I'm going to say no, A is not less than H, so this is a triangle. It's not a right triangle. It's a triangle. Could just be, it can't just be any old regular triangle because A is greater than H, yes, but A was not greater than B. So it's probably going to be two triangles. So if it's two triangles, A has to be greater than H. Is A greater than H? Yeah, same as if it's just a regular old triangle. But also, is A less than B? Yes. To be or just any old regular triangle, A had to be greater than B. But if A is less than B, that means we have two triangles. This is the ambiguous case, or an ambiguous case. That means the measurements that we've been given could make not two triangles in one. That's not what it means. It means two separate triangles with different measurements is possible. If I could have shown y'all that dang video yesterday, did anyone go home and watch it? No one? I am shocked. If I could have shown you that video, you would have a visual of like, how could it possibly be two triangles? Two different triangles, not two in the same one, two different triangles. We could show you that video, then that would make sense or more sense. Okay, well, so if it's two triangles, which it is, we have to solve both of them. But you're going to start with start with sign, with a law of signs, with what you know and something that you're trying to find out. Okay, that's how you would start. So we know A over sine at A. And at this point, I'll try to find a B over sine at B. So that would be 54 over sine at 40 degrees equals 62 over sine at B. Okay. So I could either start solving this by multiplying both sides by the sine at B. I could do that. Or I'm just going to do what I told y'all on the last one. Find the cross product. And it doesn't matter which one I do first. Okay, I just usually start with the numerator on the left. So 54 times the sine at B equals 62 times the sine at 40 degrees. Oh, goodness. That's okay. I did mark you absent though, so you'll probably get a phone call home, but I'll fix it, but it might have already gone out. No, I know. What do you do? Got some good steps in today. All right, now what do I do? Divide by 54. And that gives me sine at B equals, what do y'all get when y'all put that in your calculator? And at least give it to me in the nearest thousandths. 3 places out. 0.738, that's what I got. Now I'm just going to leave that big number in my calculator, but on my paper I just wrote the rounded number. Okay, but I want my answer to be precise as possible. So is that the measure of angle B? No. How do we find the measure of angle B? Inverse. So the inverse of 0.738 will give us angle B. So I'm leaving that big number in my calculator. And then I just push second sine to get sine inverse. And that equals, we said angles to the nearest degree. So what would that be? Nearest degree, 48 degrees. Make sure you round to whatever the directions tell you to round. If I forget to tell you to round, ask me, so that all of our answers should be exactly the same. All right. So angle B is 48 degrees, but listen. What the issue is because there's two triangles, there are actually two angles between 0 degrees and 180 degrees that can have a sine of 0.738. Because think about a unit circle, right? In quadrant 1 and quadrant 2, isn't your sine positive? So in quadrant 1, I could have an angle that has a sine of 0.738, and in quadrant 2, I could also have another angle that has a sine that's positive 0.738, right? So I have to figure out, okay, well, one of those angles, in one triangle, angle B is going to be 48 degrees. But in the other triangle, what would it be? So this is how you figure that out. And of course, we're going to write a little explanation, because when you go back and read your notes, you're like, what? Why did we do that? This was crazy. There are two angles, two angle B's between 0 degrees and 180 degrees that have a sine of B equal to 0.738. One angle B, I'm going to put angle B sub 1, so I'm just talking about one of my angles, is 48 degrees. Could be. That's what I just found on the other side, right? But to find my other angle B, because remember, two separate triangles, to find angle, we'll call it B sub 2, all you got to do is take 180 degrees and subtract that 48 degree angle. There'll be like supplement 3. And that will be 132 degrees. Say it again. Move it up. Is that better? So we used B and sine of B because we did not know angle C and we did not know side C, okay? So we did A over sine A, we knew both of those parts. And the reason I did not choose C and sine at C is I did not know either one of those. And so that angle C could be the one that's two different angles or not, or whatever. So you want to use the other leg that they gave you, which was B. So that's all we did here, B over sine at B, okay? All right, so angle A is going to be the same for both because they told us angle A is 40 degrees, correct? So I'm going to draw two triangles. One of them, angle B will be 48 degrees. The other one, angle B will be 132 degrees. And my triangles are not drawn to scale. They're both going to look the same, even though we know realistically 132 degree angle is different than a 48 degree angle. But to me, visually, that's just what I'm doing, okay? Are we cool with that? All right, so we're going to continue this on the next page. Example 3 continued. Since we have two triangles with the given conditions, we have to solve both. So like I said, these are not drawn to scale. I'm just going to draw two that are just labeled A, B, and C. They told us angle A is 40 degrees. That's the same for both triangles. In one of my triangles, B is going to be 48 degrees. And the other triangle, B is going to be 132 degrees. They told us that side A is 54, so that's the same on both. And they told us that side B is 62, and that's the same on both. Obviously, these triangles will look different. One is obtuse because of the 132-degree angle. The other is not, right? Again, not drawn to scale. If you're going to get confused, make a little note. Not drawn to scale. Now, do we have enough information that we can solve both of them? Yeah. Are we all going to do it the same way? No. We're going to have to use law of sines, though, right? Because neither of them are right triangles. All right. Do y'all want to solve them on your own, and then we'll check? Or do you want to do it together? Okay. I agree. So everybody might want to use pencil just in case you make a mistake. Or you can just redo it all if you do, whatever, and then we'll compare. Y'all ready to compare answers? Yes? Okay. Unfreeze my screen. So on the triangle with a 48-degree angle, angle C is 92 degrees, and then side C, that rounded to 84. And then on the triangle with B is 132 degrees, that means angle C would be 8 degrees, and side C rounded to the nearest tenths, because that's what the direction said, 11.7. I'll scoot it up a little so you can see it might work. Anybody have questions on that? Anybody want me to show you my math calculator work, anything like that? Okay, did you do A over sine at A equals C over sine at C? Okay, was yours the same here? Okay, even if you didn't, we should still get the same thing. So if you didn't do the cross multiply, if you did 54 divided by sine at 40 degrees equals C over sine at 8 degrees. So you multiplied both sides by what? Oh, okay. Anybody else do it? I'll just do it. Multiply both sides by the sine at 8 degrees. This is what you do if you do not do the cross product. So C equals, and remember in your calculator, this means sine of 8 degrees times 54, or 54 times the sine of 8 degrees, which I would do 54 times 8 sine equals, divided by 40 sine equals 11.69, which is 11.7 around the nearest tenth. Any other questions on that? All good?